Greetings, intermediate algebra students. Time for another online lesson today, starting chapter 9, and we have a special treat for you guys coming up in just a matter of minutes. But anyway, this whole chapter is on exponents and dealing with them. And so first of all, this first lesson is on multiplying monomials. Now you might wonder what in the world is a monomial. And you may remember from your English days that the prefix mono means one. So that might give some hint as to what's going on here. So here's the official definition below here. A monomial is a number, a variable, or a product. Product, of course, means multiplying of a number and one or more variables. So here we have several examples of monomials. Notice it could be a single number or a single variable or some combination of them, but notice they're all multiplied together. A lot of times when we talk about monomials, we'll talk about chunks. So notice that each of these is kind of a big chunk. Here's some non-examples. Notice that anytime we are adding two variables or subtracting, then that's not considered a monomial. There's actually two of them there. And anytime we're dividing expressions like that, that's not a monomial. Now our next feature some guest speakers here today. And the first person who is able to correctly identify each of these three people, I'm going to give some bonus points on the right side of the assignment card. So this is something you should copy into your notes, this little table here. But I'm going to turn this over to our guest speakers. Listen carefully. See if you can identify who they are. Just a hint, it's not like the President of the United States or anything like that. These are people that you have probably seen around school. So here I'm turning this over to my first guest speaker. Here we go.
Alright, the first one is product of powers, and the rule is a to the power of m times a to the power of n equals a to the power of m plus n, and the example would be a to the fourth power times a to the third power equals a to the seventh power.
The second one is power of a power. The rule is a to the m to the power of n equals a to the power of mn. An example is a to the power of 2 to the power of 3 equals a to the power of 6.
This next one is very important. It is called the power of a product. You take the quantity a times b to the m power, and it equals a to the m power times b to the m power. An example is 5n to the third power equals 5 to the third power times n to the third power.
All right, so you heard those three speakers, everybody. Remember, the first person who can come from each class, so my section, also Mr. Storbeck's section, if you can tell us who these three guest speakers are, that would be really good. All right, I'm going to pause the video here to let our guest speakers excuse themselves, and then we'll be back right at you here in a second. All right, and here we go. The last rule is the power of a monomial. And again, this is really just saying that whatever powers we have on the inside of the parentheses, if you're taking a power on the outside, that means that the exponent has to be multiplied by each of those. So here's an example. And notice with the a variable, it's a to the 2 times 4, b to the 3 times 4. Now, these are kind of strange. You might have seen these a bit before other years, but we want to practice on some problems coming up next. Now, what we'd like you to do is write these down and pause the video and see if you can just take a stab at what you think the correct answer is. And then I'll go over what the answers are. Keep in mind, we'll be practicing these in class a lot the next couple days, so don't worry if you're a little bit confused. So, go ahead and write these down, pause the video right now, and then I'm going to actually tell you the answers for each of these. All right, first one, x cubed times x squared. Again, it's tempting to multiply those two exponents, but you remember from looking at that rule and listening to one of our guest speakers that what I really want to do is add those exponents, and so it's going to be x to the 5th power. By the way, if that bothers you a little bit, why the answer should be that instead of x to the 6th, you might just want to kind of go off to the side and you know that x to the 3rd means this, right? X times x times x. And x squared, of course, means x times x. Whoops, like that. So now I'm multiplying them together. How many x's do I have here? Well, you can see that I do have not 6 of them, but I do have 5 of them. Hence, that's why my answer is x to the 5th. All right, next one, k to the 3rd, all that raised to the 4th power. So here all I have to do is multiply 3 times 4. So my final answer here is going to be k to the 12th. All right, next one, 3r to the 2nd. Now here, whatever's in the parentheses, I have to take to the 2nd power. So 3 to the 2nd power and r to the 2nd power. I then simplify it when I can, so 3 squared is 9, and then r to the 2nd power like that. All right, and finally, the last one. The last one is fairly similar to number 3, where everything in those parentheses I have to take to the 3rd power. So I have 2 squared to the 3rd power, and then q to the 5th to the 3rd power. So my final answer ends up to be 2 to the, and then I have to multiply 2 times 3, which is 6, and then q to the 15th. Now 2 to the 6th power, I think is, let's see, 2 to the 4th I think is 16, 5th is 32, so 2 to the 6th power I believe is 64. So my final answer here would be 64 q to the 15th. All right, thanks for listening, everybody, and we'll see you guys in class. Don't forget to take a stab at our 3 guest speakers that we had for this lesson. Bye now.